A tutorial video is a video where we work a few challenging questions, the ones that we have on the board, and hopefully most of you will gain the much needed experience in tackling these questions. So before we start the tutorial, I would like to introduce another type of number which is called a perfect square. Perfect square. If we ever tried to find the square root of, for example, find the square root of 5. So if you're asked to find the square root of 5 without a calculator, it can be a very difficult situation. Huh? So, but if you're asked to find the square root of 4, it's very simple. The square root of 4 is 2. The square root of 4 is 2. So 4 is a perfect square and 5 is not a perfect square. So many times you're going to be asked to change a number into a perfect square. We are going to find a question where you are asked to find the square root of a number. In paper 1 where you don't have a calculator, you're going to use the method that I'm going to show you. One of the questions in such a question require you to use such a method. So let's start. First question, express 252 as a product of its prime factors. So remember the tree method. 252 is a product of its prime factors. So we have two branches, one for the remainder and one for the prime factor dividing. So remember our prime factors are 2, 3, 5, 7, and so on. So the smallest prime factor is 2, divide by 2, 2 into that, we have 1, 2 into that, we have 2, remainder 1, and a 6 here. So we move on, we put our branches, we divide again by 2, 2 into that, 6, and 2 into that, 3. So again, we put our branches here. After putting our branches here, can 2 enter into this? It can't, it leaves the remainder. So if 3 can enter into this, we put 3 here, 3 into that, we have 2, 3 into that, we have 1, so 21 here. Again, you put your branches. So what prime factor enter into this? Another 3. So 3 into 21, you have 7. 7 is a prime factor. So you have used the tree method to find. Then you express your answer as 252 is equals to 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 7, which is equals to, these are 2, so you can say 2 to the power 2 multiplied by 3 to the power 2 multiplied by 7. That's the product of its prime factors. That's the first question. Let's move on to the second question. You are given that 294 is expressed as 2 times 3 times 7, and you're also given 784, which is expressed as 2 to the power 4 multiplied by 7 to the power 2. You're given that, and you're asked to find the smallest integer, which is a factor of this one and this one. You are asked to find a smallest integer. This is the key point. Smallest integer, which is a factor of the two numbers. So they do not tell you directly that you have to find the highest common factor. If you see language like this one, find the smallest integer, which is a factor, just know that you are being asked to find the highest common factor. So we write part 1, highest common factor. You are being asked to find the highest common factor. You have to deduce the language. So in order to find the highest common factor, we take the common base. We take the common base. And lowest power. Take the common base and lowest power. So our highest common factor, 2 is the common base. 2, lowest power of 2, we have 1. 3 is not a common base. 3 is not a common base. So we take 7. 7 is the power 2. So 2 to the power 1 multiplied by 7 to the power 2. That's going to be 2 multiplied by 49, which is going to be equal to 98. That's going to be our answer for part 1. So let's move on to part 2. Let's move on to part 2. So in the second part, we are asked to find the square root of 784. You are asked to find the square root. You are asked to find the square root of 784. So 784 is expressed as a product of its prime factor, which is 2 to the power 4 multiplied by 7 to the power 2. So I want you to look closely at this one. You want to find the square root of this one. So what we can do is say 2 to the power 2 multiplied by 7. You put a bracket here to the power 2. I haven't changed anything yet. I've just taken 2 from this power and taken 2 from this power. So you remain with the power 1 here. Then after this, we put our square root sign. Square root, we put our square root sign on both sides. So any number which is squared and there's a square root sign, they cancel out. So you remain with 2 squared multiplied by 7 to the power 1. 2 squared is 4. 4 multiplied by 7, which is 28. So that's your answer for the second part. That's your answer for the second part. So let's move on to the next question. Let's move on to the next question. Write down the prime numbers between 30 and 40. So I want you to write these in the comment section. All the prime numbers between 30 and 40. I want you to write it in the comment section. So let's move on. Part 2. Write down a number which is both a multiple. Yeah. Look at this. Write down a number which is both, key point here, it's both a multiple, that's the key point. So if you see both and multiple, write down a number which is both a multiple of 12 and 18. You then realize that you are being asked to find the lowest common multiple. You are being asked to find the lowest common multiple. So firstly, we express 12 as a product of its prime factors. You have 12, then 2, 2 into 12, 6, then you have 2, again, that's 3. So 12 expressed as a product of its prime factors, that's 12 is equal to 2 multiplied by 2 multiplied by 3, which is 2 squared times 3. And you have 18. We express 18 as a product of its prime factors. 18, that's 2 here. 2 divided by 18, we have 9, then 3, then we have 3. So 18 is a product of its prime factors. Is given by 2 multiplied by 3 squared. So we have these two. So the lowest common multiple is given by the common base in the highest power. So 2 is a common base. Look here, the power is 1 and the power is 2. So we take 2, the highest power. Then we look at this one. If you look at this one, 3 is a common base. And we take the highest power, 3. So we are going to have 4 multiplied by 9. 4 multiplied by 9. So that's going to be our lowest common multiple. So let's move on. Let's move on. Expressed as a product of its prime factor. Expressed as a product of its prime factor. 190. It's given by 2 multiplied by 5 multiplied by 19. 90, it's given by 2 multiplied by 3 squared multiplied by 5, expressed as a product of its prime factor. Find the smallest integer k such that 190k is a perfect square. So you're asked to find the smallest integer k such that 190 is a perfect square. So you're given this number 190k. Given this number 193, we need to make this number a perfect square. So if we have a value here and a variable here, you realize that there is a multiplication sign in between. So you have 190 multiplied by k. So you have 190 expressed as a product of its prime factor. 190 expressed as a product of its prime factor. You have 2 to the power 1 multiplied by 5 to the power 1 multiplied by 19 to the power 1 multiplied by k. So remember I told you in order to make a number a perfect square, the powers of the prime factors must be even. Is 1 an even number? 1 is not an even number. So the smallest even number is 2. So in order to make these powers 2, we are going to multiply with the same basis and the same power. So we are going to have 2 to the power 1 multiplied by 5 to the power 1 multiplied by 19 to the power 1 multiplied by, we start again, 2 to the power 1 multiplied by 5 to the power 1 multiplied by 19 to the power 1. So the given number is going to be 2 to the power 2, 5 to the power 2 multiplied by 19 to the power 2. So this is the smallest perfect square. So in order to make the smallest perfect k, we have assumed that our k is equals to this value. So the answer is going to be k is equals to 2 multiplied by 5 multiplied by 19, which is equals to 190. That's your answer. That's going to be your answer. Then the last question is find the highest common factor of 190 and 90. So you are already given you are already given that 190 is equals to 2 multiplied by 5 multiplied by 19, and you are given that 90 is equals to 2 multiplied by 3 squared multiplied by 5. And you're asked to find the highest common factor. So in order to find the highest common factor, we take the common base and we take the lowest power. So we take the common base 2. All of the 2 have power 1, but the lowest power. 3 is not a common base. 5 is a common base. We have a 5 and a 5. So we are going to multiply by 5 to the power 1. So we are going to have 2 multiplied by 5. And the highest common factor is going to be 10. So this is how you tackle questions that we have covered so far. Remember that the syllabus is made out of 3 sections. Syllabus is made out of 3 sections. In the first section, it's numericals. In the second section, it's calculus. In the third section, it's going to be computations. So we are still on the first section, numericals. So we'll cover the first topic on numericals. So when you come, we're going to cover the next topic on numericals. Then when we're finished in numericals,